Hello everyone, my name is Oscar and this is the 24th episode of Java Game Development. In this episode I will be going over loading your very own 3D model into the lightweight Java Game library. Now for this I'm going to be using the Stanford Bunny 3D model, which you can download off internet for free in a non-piracy like way. Okay, so this is the Stanford Bunny. And this is what we are going to be accomplishing in this, or maybe the upcoming tutorial. So I'm using a program called Blender here just to load the model and show it to you, but also to add normals to this model, because frankly there aren't any normals included with this model. And if you don't know what a normal is basically an arrow pointing in the direction of where a vertex should be pointing at, if you get what I mean. Yeah, if you get what I mean. So without normals you can't really do any lighting. So what Blender can do is it can invent the normals for you, and to do that we're going to load the file into Blender, as I've already done here, and go into File, Export, .obj. Let's go to our source directory and save it under bunny.obj, and also don't forget to include the normals. Okay, let's export the obj, and there we have it. The 3D model is finished. So when I go to the 3D model, open it with, say, text edit. I've actually already opened it. Here it is. It's in a non-binary format, so you can read it. It's very easy to understand. You basically have three sorts of different lines which you should pay attention to. The first type of line is the vertex line, and this indicates a vertex. Very simple, just V and then X, Y, and Z. The second type of line is, hang on, I just want to use vertex. No. Very large file. The second type of line is the vertex normal, and this line indicates a vertex normal. Basically the direction in which a vertex should be pointing. Again, Vn, X, Y, and Z. Very simple. Now the last type of line is the face line, and this line connects the dots, you could say, and assigns the normals to the dots by using the indices of the vertices and the normals and combining them. So you have three components, I guess you could say, X, Y, and Z, kind of, but not really. These are basically the 3 points of the triangle. So we have the vertex, then we have a slash, and then we have nothing, or a texture coordinate or anything, but that's not what we're going to be doing right now. The third one is actually the vertex normal indice. So vertex indice, vertex normal indice, vertex indice, yeah. 3 times, and you combine them and you get a triangle. Now, since there's no real library out there that's going to load this for you, we have to write our very own parser. To do that, we're going to be creating a class called model. And this class will represent basically the file with the vertices, the normals, and how you connect the vertices and the normals, the faces. So we're going to create a public list of type vector3f, not the Java x.vecmath, because you don't have that one. Here, this one. Vertices is new array list vector3f, and there we go. do the same for the normals. Just create a nice big array where we can store these things in. And lastly, we're going to store the faces. But to store the faces, I'm actually going to create another class called face. And this class is going to store the indices to the vertices and to the normals. So public vector 3f vertex. And this is actually kind of confusing because I'm using a vector 3f class here. But it's not really a float, and neither is it a vector. These are 3 indices for the vertices. Nothing else. 3 indices. So let's just add a comment. 3 indices. Not vertex. Not vertices or normals or whatever. Now let's do the same for the normals. And let's also initialize them to new vector 3f and then nothing. Now constructor public face vector 3f vertex vector 3f normal. Assign these variables. There we go. Now we can create a list of faces. And use that for our model class. Let's just create the default constructor here. Okay. There we go, we're done on the data side. Now we want to create a class that loads these things in. So we're going to create a class called OBJLoader. And let it have a static method called public static model load model file f, and we're also going to make it throw file not found exception and IO exception. There we go. Okay. Now, to load in this file line by line, we're going to be using a class called buffered reader. So we're going to create a new instance of buffered reader, call it reader, and say new buffered reader, new file reader, and then of course our file. Then we're going to create our instance of model, which we're going to return at the end of this method. And then we're going to create a new string called line and do while line is reader.readLine is not null. And here we're going to parse the stuff. So what does this actually do? Here it goes by the file line by line, and then when it hits the final line, it quits the loop, the while loop. So now I can do stuff like if line starts with and then a VN or an F, then we're going to split the line into 4 different pieces, the prefix and the 3 components. Actually, with faces we're going to split it into 4 pieces, and then this is going to be split into 2 pieces or 3 pieces as well. So let's start with the vertices. If line dot starts with v float x is float dot value of line dot split space 1. Very long line, very confusing line, so I'm going to explain it bit by bit. So we create a new float, which is x, the x component of the vertice. Then we say float dot value of, which parses the string we're going to get by splitting the line into a float. And then we're going to call line dot split into spaces. So this will split the line, let me see, go back to the vertices, into basically everything where there's a space. So this would be the first index, this would be the second, this would be the third, and this would be the fourth. So we're going to go for the second, because the first is the prefix. And we're going to do this for the y and the z coordinates too. There we go. And now m dot vertices dot add new vector 3f x, y, and z. Okay. Now, else if line dot starts with vn, we're basically going to do the same thing, but we're going to replace vertices by normals. And then do else if line dot starts with f, which is going to be the face. Now this is actually a bit more difficult. I'm going to create vector 3f, oops, this is going to be the vertex indices, say new vector 3f, the x coordinate will be float dot value of line dot split space 1 dot split the slash and then 0. That's not the entire statement, that's just one component, although the other two components are very similar to this one. So we split the line into spaces just as we did before. So we now have this, and then we split it into slashes. So this is the first part, and this would be the second part, and this is the third part. So what do? We take the first part, because that's the first index of the vertex for this face, for this triangle. Now let's say float dot value of, this is for the y component, the y index I should say. Line dot split space 2 dot split, what's this? Revert. Dot split and then the slash 0. We do the same as with the x coordinate, but now with this here. So we refine this to this. That's all there is to it really. And surprisingly we're going to do the same for the z coordinates. So z indices, of course, not coordinates. Again, we take the last one and then refine it to this one. Okay, so now that we have the vertex indices out of the way, we can start with the normal indices, which are very normal. That was a very bad joke. Okay. So actually we can just copy this, and the only difference there is between these two is that this is actually going to be the third, or the third part of the slash, and not the first. Third is of course 2. Because for some odd reason all arrays start with 0 and not 1. God knows why. So now we do this, this, and this for the normals. So now we have our triangle. We can create our triangle. m.faces.add, and then new face, vertex indices, and normal indices. I believe that's everything we have to do in the object loader file. So we've now successfully gone through all the parsing. Congratulations for staying with me. Now here I've created a class which is basically the class of episode 19. And the only difference is that I've stripped out all the drawing and the fog and the lighting. Well, there wasn't really any lighting. And I've also added a nice standard code automated editor full thing, so that we don't have to get all this stuff in the way. Okay. Also have a display list called object display list, in which we're going to draw the object, in this case the Stanford bunny. Now let's say model m is null. Try m is obgloader.load model, new file, source slash episode 24 slash bunny.obj. And now we can catch the nice exceptions. If we do catch an exception, I immediately want to destroy the display and quit the program. Like that. And then do the same, let's see, IO exception. Print the stack trace, destroy the display, and quit the Java virtual machine. Oh, and before I forget, we're actually not done with the object loader. I want to close the reader, because that's what you do when you clean up after you're done. So close the reader. There we go. Now I don't have to feel guilty about resources lying around somewhere. Okay, so now we've loaded the model, and by this here, we are sure of it, that the model is actually loaded and not just half-assed loaded like it would be here. Okay, now we can start the drawing. GL begin, GL triangles. And of course GL end. And in between we're going to iterate over every single face in all our faces of the model. And this is probably the most boring part of this episode, because it's very repetitive. But believe me, it will pay off in the end. So effects here, 3f normal 1 is m.normals.get cost int here, and then face.normal.x minus 1, because of course array indices start with 0 and not with 1. And now GL normal 3f n1.x, n1.y, and n1.z. Do the same for the vertex I mean. Vector 3f v1 is m.vertices.get cost int face.vertex.x minus 1. copy this and do this for 2 and 3. 2 and 3. I actually should call GL vertex 3F. There we go. This is going to be N2, the Y coordinate, V2, and 3, V3, Y, and Z. And called GL vertex 3F, v2.x, v2.y, and v2.z. Do the same here. Now if everything works out, it should work. And when I say it should, it probably doesn't. But if it does work, then I'm going to end this episode. No, just kidding. Also going to call GL Polygon Mode, GL Front and Back, GL Line, so we have wireframe mode. Oh my god, it actually worked. So, here you can see the result of what we've been doing for the last 21 minutes. This, ladies and gentlemen, is the Stanford bunny. When you look more closely at it, you can see it is actually a combination of one hell of a lot of triangles. Just look at it like this. You can go into the intestines of the bunny. Oh, this is epic, don't you think? So if you've been following on Twitter, I originally posted the bunny with points, and that's because I pretty much neglected, let's see where it is, drawing. That's because I neglected the triangle part. I neglected the faces entirely. You can still do that, by the way, by calling GL points. Now we have a bunny with points. Pointy bunny. See? And you can, the cool thing about this is that you can now do this with every single object 3D model file out there. Just import it to Blender, export it with the OBJ format, including normals, and then you can load it in here. And that's what I think is the real beauty of 3D models. Now you might have noticed there isn't any lighting on this yet, but there could be, if you understand what I mean. Because if I remove this, it's no longer wireframe mode and it's just a solid mesh. But since we haven't done anything with lighting yet, there's not really much to see here. It's just the silhouette of a bunny, which is cool, but it's not what you want, and it's not how we can prove that everything is consisting of triangles, which is of course the coolest thing. Anyway, I think I'm going to end this episode here. Oh wait, I'm not. There's one more cool thing I want to show to you. So, while doing this, I encountered this very odd, I guess you could call it a visual artifact, where the bunny started doing all kinds of weird things. And that was not the ill bunny, because that was another problem, but this was due to the Z buffer, because my Z near was far too low. Because if you put your Z near to, say, something really abnormally low, you can see that you have to, when you have the bunny like this, have I just put the Z far, or is that, okay, maybe a bit lower, because, or a bit higher, because now you can't see anything. There we go, that's, yeah, this is what I, that's actually not what I meant, but it's still very funny. No, I meant this effect. So you have the bunny perfectly normal, and then when you go to a certain distance, it starts getting jagged, I guess you could say, around the edges. And it starts really freaking out. Like, I don't know if you can really tell in the video, but it's kind of freaking out on my screen. Keep in mind, put your Z near value to the highest value possible. So you'll prevent this kind of weirdness, I guess you could say. Okay, this was episode 24 of Java Game Development. Stay tuned for the next episode, in which I'll automatically... let's just move away from the typo. Okay, so next episode I'm going to be covering more of shaders, or I'm going to be covering textures for models. Either one of those two things you decide in the comments below. If you want to stay notified of my latest and greatest, follow me on Twitter. If you have any questions, you can tweet me, send me a mail, or send me a YouTube private message. By the way, my Twitter name is @CodingUniverse. See you next time. Bye.